Let us consider this problem. How many milliliters of 0.1 molar HCl are required to react completely with 1 gram mixture of sodium carbonate and sodium bicarbonate containing equimolar amount of both? Here the atomic mass of sodium, carbon, oxygen and hydrogen are given as 23 atomic mass units, 12 atomic mass units, 16 atomic mass units and 1 atomic mass unit respectively. First of all, let us write the given data. The molarity of HCl is given as 0.1 mole. Secondly, it is given as 1 gram mixture. So let me represent this as mixture, Wm. This mixture consists of X plus Y, that is X is the weight of sodium carbonate Na2CO3 and sodium bicarbonate or hydrogen carbonate. So together it weighs 1 gram. So it means X plus Y is equal to 1 gram means Y is equal to 1 minus X gram. So we have X gram of sodium carbonate and 1 minus X gram of sodium bicarbonate. Now we have to calculate the sodium carbonate molar mass of sodium carbonate. We know the atomic mass of sodium is 23. So 23 into 2, 46 plus carbon 12 plus oxygen 3 into 16, 48. So that gives 106 gram per mole of sodium carbonate. That is the molar mass of sodium carbonate. Similarly, sodium bicarbonate NaHCO3. So it is 84 gram per mole. So based on the weight and molar mass, we can calculate the number of moles because we know this equation, that is number of moles is equal to weight by molecular weight. So based on that, we can find out the number of moles of sodium carbonate in terms of weight of sodium carbonate divided by molar mass of sodium carbonate. We have got the weight of sodium carbonate, how much? X gram. And the molar mass of sodium carbonate is 106 grams. So X by 106. So similarly, NaHCO3, number of moles of NaHCO3 is equal to, its weight is 1 minus X gram divided by 84 gram per mole. Okay. Since it is given as equimolar, their moles should be equal. It means X by 106 is equal to 1 minus X divided by 84. So this is the important derivation we are given based on the given statement, that is equimolar, right? And this part is the number of moles of sodium carbonate Na2CO3 and this part is the number of moles of sodium bicarbonate, right? So we can cross multiply and get the value of X based on this equation. So we have got X is equal to 106 divided by 190 and that is equal to 0.5578 gram, which is nothing but sodium carbonate weight of sodium carbonate. And we know already the weight of sodium bicarbonate is 1 minus X. So 1 minus this 0.5578 is equal to 0.4422. Okay. So we have got the weight of sodium carbonate, we have got the weight of sodium bicarbonate. Got it? Based on that, we can work out the number of moles of sodium carbonate as well as sodium bicarbonate. Let us work out sodium carbonate. So N of Na2CO3 is equal to weight of sodium carbonate divided by molar mass of sodium carbonate. So we have got the weight of sodium carbonate as 0.5578. So 0.5578 divided by its molecular mass. Okay. Similarly, for NaHCO3 we can achieve 0.4422 divided by 84. Now we are able to get the number of moles of sodium carbonate as 5.262 into 10 power minus 3 mole. Similarly, for sodium bicarbonate 5.64 into 10 power minus 3. Right? Now, based on that, we can work out the equation. We know, let us consider this part. Sodium carbonate combines with the 2 moles of hydrochloric acid to give sodium chloride, 2 moles H2O plus carbon dioxide. Similarly, here sodium bicarbonate that combines with HCl gives a sodium chloride plus H2O plus what? Carbon dioxide. We can combine together so that we have got 3 HCl. It means 2 moles of HCl is required to neutralize Na2CO3. So what does that mean? So 2 moles of HCl is required to neutralize Na2CO3, means that is we have to multiply 2 moles of number of moles of Na2CO3, the equal number of moles of Na2CO3. And similarly 1 mole of HCl means 1 mole of NaHCO3. So 1 into 5.6264 into 10 power minus 3. Okay, and this is 2 into 5.62 into 10 power minus 3. We can add, making 10 power minus 3 as common. So we are able to get 0.0157788 mole per mole, this much number of mole. And here we can simplify, reduce this, truncate this digits as number of HCl, moles of HCl as 0.0158. So M, the molarity of HCl is equal to number of moles of HCl into 1 by V. And V is nothing but number of HCl divided by molarity of HCl. So in this case, here 0.0158 divided by 0.1. So that gives 0.158 liter. But the question asked here is the volume of hydrochloric acid of 0.1 molar solution in milliliter to neutralize the 1 gram mixture of sodium carbonate and bicarbonate. Okay. So the final answer is 158 milliliter. Okay.